All right, so in part 2 here, we're going to do example 2 and solve the inequalities. Some of them are going to be quadratic, some of them are cubic, it just depends. So problem number 8, we have an inequality that we need to solve. And the first thing we want to do is to get one side of the inequality to be 0. It's the easiest thing that we can work with. And so that's what we're going to do. And what I'm doing here is I'm adding 36 to both sides, and now I have an inequality that's compared to 0. I now want to look at this left side and see what I can do to factor it. So I notice 3, 24, and 36. I can divide every single part of this problem by 3. Okay. So that's going to be 3, whoops, I'm dividing it. So x squared plus 8x plus 12 is less than or equal to 0. Now remember, if your GCF had a variable in it, you would not do this. And I believe there's an example later on that you would not divide completely, you would factor. So just be careful with that. So let's find our factored form. What multiplies to 12 and adds up to 8? Well, 6 times 2 is 12. 6 plus 2 is 8. I now have my factored form. From my factors, I am going to find my zeros. So take each factor, set it equal to 0. We're going to get x is equal to -6 and -2. Now I'm going to take those two zeros, graph them, so -6, -2. And this particular polynomial had a positive a value. So this is going to be a concave up parabola. And it's okay that it doesn't look perfect. Like if I look at that and go, has some issues, that's okay. On the left, we have negative infinity. On the right, we've got positive infinity. Now, the comparison to 0 was less than or equal to 0. So the equal to part means I'm going to use the brackets, all right, with my actual zeros. But less than 0 means I want to look at this and I want to find the function values below the x-axis. And that only happens between -6 and -2, and we're going to use brackets there. So that is the interval for our inequality. All right, so that's number 8. Let's move on down to number 9 here. Again, I'm going to focus on just the inequality. So let's see, 2, 8, 8, and 32 are all divisible by a common factor of 2. So I'm going to go ahead and divide that 2 across everything in the inequality. So x cubed minus 4x squared minus 4x plus 16 greater than 0. Little bit of GCF factoring here. So I'm going to do factor by grouping. So these first two terms have an x squared in common, leaving behind x minus 4. Now the next two terms have a 4 in common, but because I want this to match this, I'm actually going to plot a -4. So -4 is going to get me x minus 4 left over, greater than 0. So x minus 4 matches. That's this parenthesis set and this one are matched to the same, so I'm going to factor those out. And then we've got x squared minus 4 left over, but this can be factored more, so I'm going to. That's the difference of perfect squares. So x minus 2, x plus 2 greater than 0. Now each one of these factors is going to get me a 0. So I have x is equal to +4, x is equal to +2, and you'll notice all I'm doing is flipping the signs, right? And x is equal to -2. If you don't like that or you're just unsure about it, remember, take each factor, set it equal to 0, and solve it. Hold on one second. X plus 2 is equal to 0. Okay. So now I'm going to take each of these zeros and graph them as my x-intercepts. So far left on the x-axis is negative infinity, far right is positive. That's a horrible positive infinity. There we go, slightly better. So we're going to have 4, we're going to have 2, we're going to have negative 2. Okay. This particular polynomial started with a positive a value, so that means this is a positive cubic function, and we're going to start low, curve through our x-intercepts, and end high. Okay, so start low, curve through the x-intercepts, and end high. Now, is this perfect? I have no idea. If I wanted perfection, I'd grab a calculator and graph it that way. All right. What I do know is I want my inequality to be greater than 0. So greater than 0 means I want to be above the x-axis. So above the x-axis is that loop and that part of my graph. So those two intervals, and one quick thing I want to take a look at, there's no equal to part here, so you're not going to use any brackets, all parentheses here. So we start going above the x-axis right around negative 2 to positive 2, and then from 4 till infinity, we are above the x-axis. So there is our interval answer for problem number 9. All right, next question. And I believe there's 2 more. Okay, so problem number 10. I'm going to zoom in on this one. Now, I do recognize that there is a GCF here of 6, and I also recognize that there is a GCF of x. So this is one where you want to be careful, and I'm going to factor 6x out, okay, not divide it. You'll notice I did not divide the 0 by 6x. Be careful with that. The reason is, if you divide it out, you would lose one of your critical values, one of your zeros, and that would cause all kinds of problems with your graph, so don't do it. So 6x, I'm going to factor this trinomial. What multiplies to negative 2 and adds up to negative 1? Well, negative 2 plus 1. And then I'm going to take each one of these and set it equal to 0 so I can find my zeros. So let's see, x is equal to 0, x is equal to positive 2, and x is equal to negative 1. Each one of those zeros turns into an x-intercept. So negative infinity, positive infinity. We've got 0, positive 2, and somewhere over to the left here's going to be negative 1. All right, so we have a positive cubic. So we're going to start low, curve through our x-intercepts, and end high. Okay, so start low, curve. Wow, I just ran right through that negative 1. Let me actually draw the graph in first, and then I'll label that. All right, Here we go. And I'll put that label back in there for negative 1. All right, so we want to be all the intervals where we are greater than or equal to 0. So that's going to be above the x-axis. So it's going to be here to here, and we're equal to, so we're going to use those x-intercepts. And here again, and then going up. So reading those intervals, we start at negative 1 to 0, use brackets on both of those, union, another bracket here to start with 2, and then to infinity. Now, infinity is an idea that this interval is going to keep going, so infinities will always take parentheses, always, always, no brackets on infinities. Okay. All right, one more quick problem here. Well, maybe we'll see if it's quick or not. Problem number 11, solve the inequality. Now, problem number 11 has conveniently already been factored for us, which is really nice. All we need to do is take the zeros, remember to find each factor, take each factor, set it equal to 0, and find our zeros. So x is equal to 4, x is equal to -3, x is equal to -4. Each one of those zeros is going to go on my x-axis. They're going to become my x-intercepts. So I just marked infinity and negative infinity. Let's see, we've got +4, -3, and -4. Okay. Now, this is a cubic function. If I were to multiply all the x's together, I'd get x cubed. And the leading term out here, the leading a value is a +1. So that means we're going to start low, curve through the x-intercepts. Now I'm just leaving gaps there so I don't draw through the numbers. And I'm looking for where x is strictly less than 0. So no brackets at all in this problem. So less than 0 would be this part of my graph over here and this part of my graph right here. So what intervals are those? Well, it's going to be from -infinity, except that looks like a straight line there, -infinity to -4. And then it restarts from -3 to +4. So there is our interval of where that inequality is less than 0. All right, so lots of example problems here. If you have any questions or concerns, please let me know and I will help you out with those questions.